Hello. Hi guys, good morning. Welcome back to a new video. In this, we're going to see problem count triplets that can form two arrays equal XOR of equal XOR. If any word or XOR and comes in, I expect that you must have watched bit manipulation crash course to understand all the tricks and formulas used in bit manipulation. Especially for XOR, we have discussed here. Now, coming on back, again, we will discuss 5 approaches to solve this. Mostly, people will not discuss it. That's the reason we'll discuss all the approaches. Now, starting off, it just simply says that you have to select 3 indexes, I, j, and k, such that I and j should not be matching, and j and k can be matching, and I can be the starting index, j can be the ending index also. Okay, and we have to determine, and that is defined as a and b as follows. How? A is the XOR from I to j minus 1. B is XOR from j to k, right? So if I imagine, if I show you as an array like this, it will be I is here, k is here, then j, if my j is here, then I have to take the XOR from I to j minus 1 and j to k. And this XOR A and B should be equal. If that is the case, then it is a good or a valid triplet, and I have to find all such number of triplets. Now, first, very brute force again. If I imagine again, you will consider that I will take all the entire example is based on A0, A1, A2, A3, A4, A5, which means it says my nums array, which means my input array ARR, is actually having these elements like this. So as to generify everything, right? Now, very brute force approach, we need to check for 3 indexes I, j, and k, right? In which, when I have got I, j, and k, I will simply take the XOR from I to j minus 1. I'll take the XOR from j to k, and I will just simply check. If it is equal, then I, j, and k is a good valid index. So I will choose 3 indexes I, j, and k, simply 3 for loops, and on, like, while I am on these for loops, I will simply have a check of XOR from I to j minus 1, and also I'll do a XOR from j to k, which means again these 3 for loops I, j, and k will take O of n cube time. Simple. And while these for loops are executing, we will actually also need to find the XOR from I to j minus 1 and from j to k, which will again take a O of n time individually. So it will be a O of n raised to power 4 time. Now, in this kind of brute force approaches, we have already seen that, if you have remembered, when we find the sub-array sum, so we just say, okay, I to j, we will take the for loops, and then in that we will again go and find the sum, which gives you O of n cube time. But then we also figured out that it is not required for us to take another O of n here, which means while I'm generating the sub arrays itself, I can keep on computing the sum, which means I to j is here. Okay, it is a sum right now. I to j is here, just increment one more element, add one more element. J is here, add one more element. J is here, add one more element. That is how, while making the sub arrays itself, I can compute my sum. In this case, while generating my for loops itself, I can compute these XOR values itself. How? Simple. Again, I'm just showing you now that this will not be used, that separately I don't need to compute the XOR. While generating my IJK loops, or basically by generating all the subarrays, I should say, I will ultimately also find my XOR. How? I will take I, J, and K. Remember, I to j minus 1 is XOR A, it is XOR A, and j to k is XOR B. So again, I, j, and k, I to j, I want the XOR A. So I'm getting the XOR A. Again, here j is I plus 1. That's the reason I am doing a ARR of j minus 1. And then from j to k, I want the XOR B. So I'm again doing a ARR of k. And thus, this will show that while doing a for loop itself, I'm computing my XOR parallelly, both XOR A and XOR B. And then I'll simply check if XOR is equal to XOR B, increase the answer by 1. Thus, I will simply get my answer in O of n cube time and O of 1 space. That will completely work because my constraints are 300, which is okay. Which means 3 cube into 10 to the power 6. That will work for us. Now, coming on, that can we improvise it? Now, as we start thinking of improvising, we'll look back what we were doing earlier. Earlier, we were trying for all ij and all ik's and then all j's also. If I'm saying from O of n cube I want to improvise, then for sure it feels okay that I should maybe try improvising to O of n square. Also, you might feel like, okay, what about O of n square log n? Yeah, that can also be possible. But standardly it feels like let's improvise to O of n square. If yes, then for sure I, k, maybe I can take them. Maybe I can get rid of this j itself altogether. Because if I want to transform from O of n cube to O of n square, for sure one of the for loops I have to remove. And I know, okay, start I and j are the starting and the ending. So maybe that is required much more than j, which is the middle ones. So maybe somehow I am able to figure out what are all the j's. So that's the reason I tried to remove my j. Now, okay, now we are saying, okay, I have only I and k with me. So what can we do? Let's come back again. Now I am saying that if for some random j, if we had in the beginning, if we had in the middle, sorry, I would have I to j minus 1 XOR and j to k XOR. Technically, I'm taking a XOR of some range. Now, as soon as XOR of some range comes in picture in your mind, it might click. Okay, I'm taking a XOR of some ranges, and for me as a very beginner, again, as we are doing this problem, we might feel like, okay, XOR of some range, for sure we can try to take again. When we take XOR of some range, we have to pre-compute that range XOR. And whenever pre-computation range or these kind of things comes in, you can think of maybe segment tree, Fenwick tree, or prefix sums. Now, again, this is not that big of a problem that you have to do a range queries. So for sure, we can try to think of prefix XORs. Let's maintain the prefix XOR for us. So this was my input array. I just maintain the prefix XOR for all of them. Okay, in the very beginning, XOR is 0, then A0, then A0, A1. Again, I just took A1, A0. That's the reason, because I want to generify it, not giving a specific example itself. And then A0, A1, A2, A0, A1, A2, A3, and then so on and so forth. Thus, you maintain the prefix XOR. But Aryan, like, how will the prefix XOR help me? So, what this prefix XOR firstly says, this prefix XOR says, if I want to find the XOR in the range I to k, again, XOR in the range I to k, which means I want to find the XOR from A1 to A4, I will simply do prefix XOR of A4 minus prefix XOR of A0. Same method of prefix sums. If you don't know what prefix sums are, just write on YouTube prefix sums by Aryan Mittal. You will get the video. Just watch that video. Now, so this prefix XOR computation helped me to figure out XOR in the range I to j by saying XOR of A4 minus XOR of A0. Earlier, remember, you do a minus, but here we have a XOR property, which will make sure that, again, this is the A4 prefix XOR, this is the A0 prefix XOR. Again, because I want to compute the range from A1 to A4, that's the reason I put a A0 here, which means A1 minus 1. That's the same how we do a prefix sums also. Then this minus or XOR will make sure these cancel out. This is a XOR property, and this we have already seen in the crash course video. That's a very important XOR property. Now we realize that we got the result as A1, A2, A3, A4 XOR, which is same way saying it is a XOR in this range A1 to A4. But again, Aryan, that is what I didn't need. I needed to make sure the XORs of two ranges are equal. Although, okay, you are saying that you will find the XOR of some range, but ultimately, how are you checking of something being equal? Okay, so let's say that we are trying to check, because we have only maintained the prefix XORs. So let's check if we can figure out some property while comparing the prefix XORs itself. Because I want to make some XORs equal. I have got the prefix XORs because that represented my range. So let's actually take prefix XOR and make them equal. So imagine I and k. Imagine again the prefix XOR of A1, which is this, and prefix XOR of A4, which is this, is, imagine it is same. I'm saying imagine it is same because again I want to try something equal. So I'm imagining, what if prefix XORs are same? If the prefix XOR is the same, then I can simply say this prefix XOR is same. I can simply write this as, this is the prefix XOR of A4, this is the prefix XOR of A1. I can write it as like this. If I see it very carefully, I can simply see, okay, A0 will cancel, A1 will cancel. Again, if you're just worried, okay, how it is cancelling, go and watch crash course. Now, this simply represents one very important stuff, which is A2s or A3s or A4 is 0. What it means? It means that I took a I to k as a range, and if prefix XOR of I, prefix XOR of k matches or are equal, then I plus 1, if I take I plus 1 to k, XOR value will be a 0. That's a very important property because it will help me find a number of such good groups. Again, for me, groups, I am saying I, J, and K triplets. How? I, K, same thing. You will see that, okay, this range, this XOR range have a XOR value of 0. How 0? Easily you can see 7, 7, 7, 2, 2, 3, 3. So for sure, this range is having a XOR of 0. Again, this length is 1, 2, 3, 4, 5, and 6. Length is 6. Again, I'm just replicating this exact same group, I plus 1 to K thing, right? This will help me figure out all the number of good triplets. How? You will see. It will simply, again, my claim is that if I have this specific range, I plus 1 to K, length is 6, I will have 5 such groups. How? You will easily see that. Again, remember this pink thing? Not always. So first group can be that I took a 7 and I took a 2, 3, 7, 5, 2. 7, 2, 3, 7, 5, 2. And I'm saying the XOR of them is actually same. And how I can say that? Because I know the XOR of complete is 0. So for sure, if this should for sure match with someone in the right, and ultimately everyone should counter themselves. And that can be easily proved because I am saying I have some elements. The XOR of all of them is 0. Then I took one element aside, which means the other elements will also be same, because I know if it is 0, it will be A XOR A. If it is A, for sure the result of them will also be A. That is a simple proof of why this is true. And again, I can repeat the same process. Again, I bifurcated at, let's say, first was 7. Let's say I do for a 7, 2. Again, you will see 7, 2. If I just cut it, again, right side also XOR is same. If I do a this XOR, again, exact same XOR. If I do this, again, it will cut a 2, 3, a 2, 3. If I do a this, you will see 7, 7, 3, 3, a 2 and 2. Thus, we realized if my length is 6, again, if my length is 6, I will have 5, 1, 2, 3, 4, 5. 5 such non-zero groups possible. Now, the inference which I received from entire above thing was that I have a I, I have a J. If the prefix XOR of I, prefix XOR of K is equal, then I can simply get the length, get this length, which means from I plus 1 to K, right? The length will be K minus I plus 1 plus 1. This is a length. But I realized if the length is 6, the number of good groups or number of good triplets will be length minus 1, which is 5. So I'll do a length minus 1. So I'll get a number of good groups for this corresponding thing will be K minus I plus 1. Thus, I reached to a very good property that I and K, if the prefix XOR of K, if the prefix XOR of I is equal, then the contribution in the answer will be number of these groups, which is K minus I plus 1. Thus, do the exact same stuff. Let's see the code. It's pretty simple, exactly same. That firstly, we have to maintain the prefix XOR. Again, as I showed you in the very beginning also, the prefix XOR starts with a 0, so you have to maintain a 0 also. So I have taken a n plus 1 length prefix XOR array. I just maintain the prefix XOR, simply XORing. That's a simple prefix XOR. Now I went on to my I and K, all possible values. For every possible I and K pair, if prefix XOR of K and prefix XOR of I matches, I know the contribution in the answer will be answer plus K minus I plus 1. And thus, my complexity for this will be O of n squared, because I'm only using a I and a K loop. Again, O of n will come here, but that will be again O of n squared plus n, which will be not that much. But you see that I boiled down to O of n squared as the time complexity. Again, space used will be O of n because of the prefix XOR. So that is one thing which is obvious. Can we improvise it further? Yes, obviously we can. How we know that? We know that because of simple fact of what we proved above. We proved above that prefix XOR of I, if it is equal to prefix XOR of A, I am adding the contribution in my answer as K minus I plus 1. If you look at a bigger scale, let's imagine that not only one such I is there. There are, let's say, multiple such I whose prefix XOR is same. Again, because see, you had a O of n square, which means you took I and K. Now you have to reduce it to, let's say, O of n, which means much reduction. So for sure, you have to remove one more for loop. So let's say I said I will take I and I will remove it. Okay, I will only handle k, which means I should be able to figure out for a k what are all such i's whose prefix XOR is same as that of me. But even if I figure out what will be the contribution in the answer, let's see that. So I realize, okay, my k will be fixed. I should ultimately know all such i's whose prefix XOR is same as that of me. That's what I was doing earlier. So I should be knowing all such i's, which means I1, I2 in this case, I1, I2, they have same prefix XORs. They have same prefix XORs as that of prefix XOR of k. How will they contribute? If I just ask them individually by the above method which I asked you, if I2 and k would have been having the same prefix XOR, the contribution in the answer will be k minus I2 plus 1, k minus I2 plus 1. If individually I would have asked you, I1 and k would have been there, so contribution and the answer will be k minus I1 plus 1, k minus I1 plus 1. Now, if again, for this you need to know all I1 and I2, but I am saying I will maintain this. How? I will say, okay, let's think of the ultimate contribution on k. Again, you can see this is actually the ultimate contribution on k, but this can be showed as k is coming in twice, I1 and I2, they are coming in, their summation is coming in, and then 1 is coming in again twice. So I can write the same thing as k, which is the current index on which I am standing right now, that will come twice. What this 2 represents? This 2 represents previous number of indexes having the same prefix XOR as that of prefix XOR of k, right? So this 2 is the count of the previous number of indexes having the same XOR as that of prefix XOR of k. And what is this I1 plus I2? This is the summation of indexes having the same prefix XOR as that of k. Again, this 2 is the same count as that of this, and 1 is as it is. So if I'm standing on the index k, I should technically maintain this count, which is the count of number of indexes having the same prefix XOR as that of k, and also I should maintain the sum of those indexes also. If I'm maintaining this, I'm good to say at every point, which means at every k, I will be finding my answer in just O of one time by this formula. Cool. Let's see the code. It's exactly same. That firstly, what we will do, we'll maintain the prefix XOR as what we are doing earlier also. Now, only thing remaining is we'll maintain the sum of all the indexes having the same prefix XOR, and also the count of those indexes having the same prefix XOR. So this is count, this is sum. Now again, you know, in the very beginning, I have a prefix XOR of 0. So for that XOR, like a prefix XOR of 0, the added in the summation will be 0, and prefix XOR of 0, count will be 1. Now comes the big point. I will start with all the possible prefix XORs starting from 1, right? And then I will, I'll check for the index k, the current XOR is x, right? I should know the count of x earlier. I should know the sum of all the indexes having that x earlier. I should know the count of x earlier. And again, just k into count minus sum minus 1 into count. And that is how I will simply add the contribution in my answer, and ultimately make sure to increase the count of x, and also the summation of x increase with the index, add the index in the summation. And that's how I can simply, as you can see, this is the O of n time, this is the O of n time, and thus in O of n time I am able to achieve it. And I only use the previous approach. Whatsoever I inferred from the previous approach, I just use that. Space will be O of n because I am actually using a prefix XOR array. Now, but you will see it's a simple 2-pass approach, which means your O of n and O of n here. Can we optimize it much more further? Obviously we can, because you know that we are actually using prefix XOR of k. So we are not using any much higher value, right? We are only using a prefix XOR of k. That's it. That's the only thing which we are using. So we can just simply, while iterating, we can just simply put this entire for loop, or I can say put this entire condition in this place, because I'm not using any extra stuff which is way ahead. I can keep on building my prefix XOR and I can keep on computing this also. So the only change from 2-pass approach to 1-pass approach will be putting this condition inside this for loop. How? You will see the code. I just put this condition inside the for loop and I said that prefix XOR of k, I can compute that by simply saying prefix of k minus 1 and the XOR with array of k minus 1. I just put that condition above only inside and that's it. And thus I received my time as O of n, again same time, but it is now 1-pass approach, but space will always be O of n, and that's how this is the most optimal approach for you. Again, we have discussed 5 approaches. This was the video I thought to make, because again, people will not discuss it. Even if they discuss it, and again, this is a very concise video. I tried to go as fast as possible without repeating anything. Do let me know if you liked it or not, and take care. Goodbye. To make sure, join the Discord to actually be regular and be consistent, because that's the only thing which will make you reach to any company which you want. And yeah, make sure to watch the Bitman Crash Course. That's very important. Bye bye.